Hello Math 1324 students. Here is Lesson 1, Linear Equations and Inequalities. This must be the starting point of business algebra for most students, after skipping Lesson 0, of course. If you went through Lesson 0, of course, that's better, and you have a little bit more solid background and so on, but it's okay to skip Lesson 0 because they're all preliminary materials. But don't skip anything here in Lesson 1 because they're all important. Especially this first subsection, the basic strategy. Remember this order: denominators, parentheses, and like terms. That's the order. Step 1, denominators. Step 2, parentheses. And step 3, like terms. This applies not just to linear equations, but as a matter of fact, just about everything here in this course. There are some problems that something further should be done beforehand and then doing these, or after these something further has to be done. There are variations, of course, like those, but this standard process is embedded into just about everything we are going to be doing throughout the course. So remember this: denominators, parentheses, like terms. Here's an example, and these are trivial. Do you see any denominator? Of course not, and no parentheses either. So this kind of problem begins with step 3, like terms, directly. How about something like this? No denominators, but we do have parentheses, and then after that some like terms, of course. So this problem begins from step 2. And here we have denominators as well, so this problem begins from step 1. And so on and so forth. Well, let's begin with some trivial examples. And these are, what can I say, literally trivial. So I'll try to do this as quickly as possible. Let's see, it goes like this: 3x minus 4 equals 5 plus x. And please note that 3x here and this x, these two are like terms, so I use same color. And then negative 4 and 5, these are like terms. Please note that I used negative 4, not just 4, because this negative sign is the part of the next number. You're just adding negative 4, not subtracting 4, adding negative 4. It's more convenient that way. Now, how do you solve this? Let's take the like terms together. 3x is okay, but let's move x to the other side. And 5 is okay, and let's move 4 to the other side. So what did I do? This x became this negative x. This negative 4 became positive 4. So basic strategy is this. Change side, change sign. Of course, you can do it in traditional form as well. I don't recommend it, but it works. 3x minus 4 equals 5 plus x. Here, you can subtract x from both left-hand side and right-hand side. And then in the right-hand side, x minus x, that's 0, so adding 0, so everything drops out. So we end up with, let's see, 3x minus x. So we get 3x minus x minus 4 equals to 5. But here, let me move this minus 4, so plus 4, and then plus 4, excuse me. I'm missing some spaces in between. And then they add up to 0. So we have 3x minus x, 3x minus x equals to 5 plus 4. We can do it like this too. But then again, oh wow, how many steps did I take? How many extra steps did I take? How many extra unnecessary steps did I take? So I don't recommend it. change the side, change the sign. Change the side, change the sign. And what's next? 3x minus x is 2x, and the right hand side is 9. And then we go ahead with the conclusion. X is 9 over 2. And that's got to be the answer. Is that really the answer? Let's check it out. Indeed, that's the answer. So what did I do? We simply took the like terms together. That's about it. And another thing to remember, when you change the side, change the sign. It's much easier to use, much easier to do it like that than to do it traditional, hard way, that is adding the same number to both left hand side and right hand side, blah, blah, blah. How about the next problem? Can you do that on your own? Stop the playback and go to yourself and check the answer. Did you get it? Not yet? Stop the playback and do it on your own. Let's see, did you get it? Well, here we go. Here's the original problem. And then this 3y, and then 2y. Put those two together, and then we get 5y here, as highlighted in green. And then this negative 2y, and then this 5y. Put those together, we get plus 3y, as highlighted in green. And then this negative 1, and this 6, well, they're like terms of their own, so they don't go anywhere. Now let's take the like terms together. 5y minus 3y. Change the side, change the sign. And 6 plus 1. Change the side, change the sign. And that's how we get 2y equal to 7. Y is 7/2. So much for trivial example. Okay, alright, let's go to a little bit less trivial example, this time linear equations with parentheses. Okay, these problems are a little bit more worthy. Okay, let's copy and paste this problem. And then let's go to the basic strategy. Denominators, no. Parentheses, yes. So we begin with step 2. And then in the end, we'll have to take some like terms together. Okay, how do we do this? How do we break up the parentheses? We have to use the distributive property. And here is the standard way. So this 4 is distributed to this 3x and also negative 2. So that's going to become x plus, now distributing 4 times 3, so 12x. And then 4 times negative 2, negative 8. That's the left-hand side. Alright, how about the right-hand side? This negative 2, okay, distribute like this. Negative 1 was there before, minus 2 times 2, 4x, and 2 times 7, all good? No, not really. Something is wrong, and please correct it. Found the error? It's right here. What happened? Well, this negative sign is actually part of the next number. Remember, subtraction is not a separate operation. It's just adding a negative number. So whenever you see subtraction or negative sign, it's just a negative number. So minus, which is typically for subtraction, and negative, which is typical for sign, have no difference at all. So negative, minus, they're the same. So subtraction versus adding a negative number, the same. So you can assume it as you're adding negative 2 times 2x minus 7, so you're distributing negative 2. Negative 2 times 2x, so negative 4x. Negative 2 times negative 7 is positive 14. Here, you don't need this circling because this is positive, this is addition plus. Here, you do need this circling in order to cut down mistakes. If you have highlighters, then you can easily highlight and you can see through. That's the best in my opinion. If you don't, use your pencil to draw a light circle around and then distribute like this so that you can cut down your mistake. Okay, here we go. X plus 12x minus 8 equals negative 1 was there before, negative 4x plus 14. And then we can take the like terms together. X plus 12x, so we have 13x minus 8 equals to negative 4x plus 13. Is that right? Negative 1 plus 14. Okay, all right. Okay, all right. 13x plus 4x equals 13 plus 8. Remember, change the side, change the sign. So this minus 4x became plus 4x. Minus 8 became positive 8. In the end, what do we have? 13 plus 4, so 17x equals to 21. X is therefore 21 over 17. There goes the final answer. Let's see, what did I do in my answer key here? Yes, the same computation. Remember this distribution at step 1. That's how to break a parenthesis correctly. And remember, circling the entire number, including the sign. Well, we have another problem like that. So stop the playback and do it on your own. Make sure you break up parentheses correctly. And if you need some assistance, circle the entire number, including the sign. And then draw the arcs. So, did you get it done? All done? If not yet, stop the playback and do it on your own. Okay, let's see, let's check. Break up the parentheses. Negative 4 times 3, negative 12. Negative 4 times positive 5z, negative 20z. And then the right hand side is much easier breakup because this is addition. 2 times negative 3 is negative 6, 2 times z is 2z. We have all those. No more parentheses, just like terms. Take the like terms together in the left hand side. And then flip this 2 to the other side. So negative 18z minus 2z. Change the side, change the sign. And then in the right hand side, positive 12. So negative 20z is 12. Okay, here's the computation. So we went through a trivial and a little bit less trivial problems. We're going to do whole problem, the entire problem, in the next video, starting all the way from the denominator.